So, well, most of us here, we are engineers. As engineer, our mission is to find the best solution to problem. So having those mental mechanisms that allow us to identify problems, recognize the properties, and apply a good solution, in my opinion, is crucial to be good engineers, and it's a massive win for the company that we work on. So what we're going to see today is what is a design pattern, what is event sorting, pros and cons and mistakes and common problems from the experience. So what is a design pattern? Well, I did what any mortal will do in my position, so I asked to the Oracle. What the Oracle says is something like is generic and reusable solutions for a common occurring problem. So it's not something that is built in, ready to be applied. It's like a formalized of best practice, a template of how to solve a problem. And sometimes it's missing, but what is also very important is like nominate. It gives a name to the solutions. And this also applies to the software development, because design pattern is something that comes from other industries, come from architecture. But why should I learn a design pattern? Well, as I mentioned at the beginning, it gives us the ability to apply good solution. It has been already tried, already tested. It allows us to identify problem in a very beginning stage, because even before to solve a problem, every design pattern has their own cons. So we know in advance what problems we have to deal with. It's very effective on the communication because it offers to us a common language. If you have to say that you create a class that has an instance of itself as an object, and you make the constructor private, and you create another method that returns that instance if it's initialized, or you can say, I did a singleton. So it gives the ability to give a name and offer all the details about yourself, about the patterns applied. And it improves the productivity, because most of us, when we arrive to a project that is already started, what is very useful is say, we apply here an observer, and here an event sorting, and here whatever else. So it gets up to speed very, very quickly. And a sentence I like it is, if you only have a hammer, you tend to see every problem as a nail. So it's very important to us to have a big enough toolkit. And that is what design pattern offers to us. So let's learn a new design pattern that is event sorting. So how many of you know event sorting? Good number. How many of you use in production? Well, much less. Okay, that's good. I want to know why you don't apply to in production. So what is event sorting? Well, a good and short definition is to record all the state change, called events, into an append-only log. Let's look at the definition. So it's a pattern that's going to tell us how to record, how to save information, how to keep data. Which data, all the state change. Basically, is what we do in traditional system, right? We save the status. And the other important thing is into an append-only log. So the only operation that is allowed is insert. You are not able to do delete. You are not able to do updates. You only can insert at the end, append. And this storage will work as a persistent layer for your application and going to be the source of truth for you. I think that is easier to understand if we compare with traditional system. So in traditional system, this is an example of a card that has items and has shipping information. We have structured data, and at the end, we persist a table that has the card ID, a customer ID, has an state, that in this case is delivered, has an amount. Is this familiar for you? Well, it's what everyone do, right? In event sorting, however, what we're going to save is the facts that happen with that card, right? We're going to save all the facts that already happened with this card. Card initialized, item added, whatever, shipping info added, order from the card dispatcher, and order delivered. We have all the information related with the card, and everybody can see how from all the events we can derive the current state. We can derive the other information. Event sorting systems are also present in real life, not just in software. What do you think about your history as a patient? When you go to the doctor and the doctor do more tests to you, it deletes the past of you and say, now you're state like you have a problem? No, it appends all the information to your history. It's also on accounting. So on banking and an account system, you don't have like a balance or an account that has an estate. You have all the history, all the record in the history that has debit transaction or credit transaction, and as a result, you have a balance. And it's also in law. When a new law appears, it doesn't replace, we don't forget or delete the existing law. It's just an append. So those systems are quite representative of what is an event sorting. Okay, let's go in deep a little bit and let's see how we can model a problem with event sorting. We're gonna explain the different elements, components of pattern. First thing is, what is an event? As we said, the event represents a state change or represents a fact that happened into your domain. It's something that is important to you. And it's more natural way, right? It's something that is immutable. We don't want to allow to change anything that already happened. We are not allowed because, as we said before, it's an insert only. And it's the source of truth, right? So example of events are item added, user registered from Android device, whatever. This account code apply. Those are just examples. And as you can see, we tend to express them in past tense because it's something that already happened. The event stream contains the history of all the events referring to a domain object. So we have not just a table or a row that they said card, and we have an state. We have an entire history of what happened with that card. We have card initialized, item added, and shipping info added. So if we read the entire event stream for your object domain, you can derive the current state. The current state can be derived. We have the event store, and it's the physical place where we save all the data. So it's just a database that is focused on a store event. There are many in the market that are designed for this, or you can use any SQL or document-based database. What is important is like you follow the rules. The rule is you only can do insert. You never can delete, never can update. The event must be stored in chronological order, events are immutable, and that will work as your persistent layer. So let me show an example of a system. So a system that we are handling as an example can be like this. We have something called order service. It communicates with the persistent layer that has all the events. What happens if we want to, the user wants to do an operation? Let's say add shipping info. What we have to do is we need to read all the events, we need to calculate the state, and if the business logic passes, we can write. If not, we're going to reject the operation. So we need to read the events. We're going to apply a function that is called aggregation, and we're going to have the status in an aggregate. We're going to validate the business rules. In this case, I made up and say, is the number of items greater than 0? If the answer is yes, we can write a new event. Something happened into your system. But what happened with the read operation? What if we want to get the status? If we want just to get the status, we're going to do a similar things, and it's called a function or a projection. We read all the events, we generate the state, and we just return to the user. You can tell me that it's not very efficient because anytime that I have to read the status, I need to replay all the events and perform the function. Well, it's more or less efficient, but we're going to see in a moment. So those two terms are also very famous on event sorting. Are projection, that is just a transformation on the event, a generic transformation that you can convert into another event, or you can convert into a view only, or whatever. And you can do as many, and they are disposable and temporary. And the aggregates, that are specialized projections that control the business logic and allows you to do insert into the event store. So, as I mentioned before, maybe it's not very efficient to replay all the events. Well, most of the most of the database or event store allows you to play many, many events in milliseconds. But you can decide to store it. You can decide like persist that current read model, let's say. So the read model is just a projection that transforms all the events into something read. And you can do as many as you want. You can have something in SQL or in a file or whatever. What is important is like you can create as many as you need. So you can create, because your source of truth is the set of events. So you can create a projection to return the state of a card, like we have seen. Or you can create another projection that has some statistics, like say how many package has been delivered. The source of truth is the string, and you can do as many reads as you want. So, well, that's more or less the pattern. It's a pattern that is not so big. But why I would like to use that pattern, when it's good to use? Well, let's see what are the pros and the cons. This is probably the most important slide of the presentation. What are the benefits? Why I want to use it? So the first benefit is like, it's a system that doesn't lose information. When you are saving the state of your car and you say that now it's delivered, you are doing an update over a column, you are deleting the previous information. You have a current state and you are losing the entire history. I assume that many of you do this as normal, but who decides that that information that you are losing has no value? How do you know that the business analyst in a couple of months doesn't going to say, I would like to know how many users, what was the time between the car initialized and the purchase. You are losing the entire history, and that information has a value, has a cost for the company. So this system doesn't lose information. It has an audit log for free. Who here is building an audit log for his system? So the audit log allows how you can trust on your audit log. The audit log verifies that all the operation occurs into your system already happened. Sometimes is matter of legal reasons. For instance, banking needs to have an audit log. Border pass needs to have an audit log. And in this way, your audit log is the source of truth, is the event store. People say that it's a time travel machine. It's funny because sometimes we want to see our system at some point in the past. How was my system? Or what was the time? What was the speed of people doing purchase in February of 2020? What we can do if we have an event source application is we can create that projection. We can play the event from the beginning until that date, and we will have our system in the exact way that it was at that date. So it's very powerful. Sometimes in production appear a bug that suddenly is solved without nothing. And what's matter of the system was in a certain state. So with event sourcing, we can play again until that date, and we can have our system and help to the bug. It's related with the replay and reshape. Maybe now you want to use a graph database or produce a data warehouse or whatever. So you just need to create the transformation, the projection, play the event from the beginning, and you will obtain. It works very well with asynchronous fails, that is, modern system are asynchronous, and also fail-safe, because at the time that the event is written in the event store, all the rest of transformation, status, etc. can be derived. But it's not free of cons. Let's see what are them. It needs more storage. Of course, we are saving much more information. Is that a problem? Well, sometimes it is, it could be, but it's not in the majority of the cases. So I will say that is cons, but it's not too much. And it's complex. When you read about event sourcing, it adds a layer of complexity. I'm not totally agree with that. What I say is different, right? It's like, it's complex for a doctor to diagnosticate a cold. It's difficult for us because we don't know. So it's a matter of learning and study the pattern. It works very well with other patterns. I'm going to be very quick here. Is with domain-driven design, CQRS, event-driven architecture, or SAG pattern. Probably you are familiar with DDD, or you heard, maybe not with CQRS, that basically consists on have different model between the commands or the writes and the reads. Event-driven probably you are familiar with. In the Saga pattern is when you have distributed system and you want that something happen transactionally, but needs from different subsystem. It's like matter of it's happening in all or in none, right? So it's like a transactional operation, distributed. Okay, applying this pattern is not something easy and when you are starting, but it's something like it's doable, of course. But it's not free of mistake, of challenge. So I'm gonna tell you some mistakes that happen to us and some challenge that we have. The first mistake is like the term event become overused. So it's, everything is an event. Event is something that is emitted by our application, is something like is a notification to the client. We need to be sure that the event of event sourcing is a fact, is something that happened in our system. In fact, I suggest to use a different term, like state change or fact, whatever. Don't use event. Because in event-driven architecture, there are also events. Our system sends events and another system reacts, so it's very important to be sure that when we are saying an event or event sourcing is like a state change. Similar with commands. And something that happened to us is at the beginning we have very small events. That is the recommendation, but you need to be sure that every event contains all the information needed to be processed, and you don't need external dependencies. I didn't mention anything about frameworks. There are many on the market that allows you with code, depending on the language. It's matter of if you like or not. They used to be very intrusive, like you use and pull out your code, let's say. It's up to you. We don't use it. And challenge. There are certain challenges when you start modeling like this. So first of all is versioning. Can I update an event? What is the answer? The answer is no, right? We say that it's immutable. Immutable is immutable. How do you notify the consumer that you changed an event in the past? What happened with the projection that you already have it? What happened with your audit log? That is one of the main benefits. You cannot trust on your audit log. And in certain cases, like is by law or by legislation, is a crime. So you cannot touch a banking record, you cannot touch a boarding pass record or any others. But of course, the event that I write now doesn't have to be the events that I'm gonna need in 2 years. I can evolve them. So at the time that you can convert one event into another version, it's fine. If you cannot transform one event to the other, it's because probably it's not the same event, so it's a different one. So there are operations, that is versioning events, but there are some techniques. I'm not gonna be deep on it. If you find yourself versioning behavior, that's something that needs to call your attention. So say like, if this event is older than this date, I'm gonna do this, and if it's in the future, I'm gonna do this other, that probably is something wrong. So probably something that you can fix if you add that information into the event creation. And always we have the pattern like copy and replace, like I have an event stream, I create a transformation, and I play the events again, and I create a new stream that I can consume. What happens if I make a mistake in production? Well, there is another sentence that says that accountant use pen and doesn't use pencil. So when they create a records and there is a mistake, they cannot delete, right? What they do is they do a compensation action. It can be different types. If I write a record that is send 1,000 and I want to send 100, you can say another record back, say 900 or whatever. So you can compensate totally or partially. What happens if I really screw up? So well, here it depends, right? If it's something like it's the initialized time, you can delete. And what you need to have clear is like delete an stream is a safe operation, but delete an event is not. So that is talking about what happened with the events and the information that contain. But the other big challenge, let's say, is the eventual consistency. People say, what happened with the eventual consistency? Everybody know what is eventual consistency? A good number. So is that our read model or projection is gonna be consistent with what is on the event store, but we cannot guarantee when. right? So it's eventually will be consistency. So let's go in deep about this. So what happened with my business logic? Well, my business logic, we say that is managed by the aggregate. So I'm gonna send a command say remove item. I'm gonna generate the aggregate playing all the events. Gonna check business logic. I'm gonna write. So at that time, car aggregate is up to date, right? Because the aggregate is strongly consistent. The only problem is with the read model that eventually will be consistent. So we cannot do, I mean, strong consistency is good, but it's very expensive to maintain. So eventual consistency, we just need to deal with it. You need to evaluate if it's affordable for your system, and probably it will be. We just need to deal with it. What we can do, there are many approaches. We can just ignore it. Are you sure that when you are looking at a website, the information that you are looking is the same that is on the database? Probably it's not. Is that a problem? Probably it's not neither. We can notify the client. The client can be looking at the screen and receive a notification, say please reload it, and will be notified when the read model is ready. We can actively wait in the server when you make a request, can write in the event store, and can actively wait until the read model is updated, clear polling, or fake the information. Most of the time when the user do a request, that request contains all the information to give him the answer, right? So while those are the main challenge, we just need to learn how to deal with them, and that's all, I think. So in summary, what we have seen here is design patterns are crucial for engineers because it gives us the toolkit that we use at work. Event sorting is a pattern that tells us how to save information. The benefit is the system that doesn't lose information and provides you an audit log for free. You don't have to do anything else. Also other benefits are time travel, asynchronous fair, replay and reshape. And the main challenge that you have to explore before go implement it is what you're gonna do with versioning and what you're gonna do with eventual consistency. So hope that this was useful, and that's all. Thank you.